Good morning. In the first session, we already discussed the theorems that comes under triangle and parallelogram. So today we will be discussing the theorems that comes under circle. So under the circle, we have we have chords of a circle, and we have angles of a circle. Then we have cyclic quadrilaterals, and then we have tangents. So today's session, we will be discussing the theorems that comes under circles. When you take chord of a circle means you are drawing a straight line that joins 2 points on a circle. This is called chord. And you can say the largest chord in a circle is diameter. It has to pass through the center. So the largest chord will be diameter. The theorem that comes under chord is you have center O and the straight line that joins the straight line that joins center and the midpoint, the chord AB. You have a chord AB and its midpoint is C. Now you are drawing a straight line from the center O to the midpoint, the chord AB. Here, this straight line will bisect the chord AB. So, you get a right angle 90 degree in the midpoint of the chord. And the converse of this theorem is the perpendicular drawn. The perpendicular drawn to the chord AB will bisect the line AB at C. So, the length of AC becomes equal to the length of CB. So, this is the theorem that comes under chord. In this one, you have to remember the chord should be the line that meets 2 points on a circle and the straight line that joins the midpoint of the chord, and the center of the circle will bisect the chord AB. Next, we have angles in a circle. You have a circle and the angle that is subtended you can say this as arc of the circle. You say this is minor arc and you say this as major arc. This is the major arc. So the angle subtended by the minor arc is x. And remember, the angle subtended by the major arc will be reflex angle. Now, let's see the theorems that comes under angles of a circle. You have a circle with center O. Now, the angle is subtended by a minor arc. You have a angle here. This is x. And you have another angle that is subtended by the same arc. But this angle, first you have subtended and you have made an angle subtended by the arc at center, and the second angle is subtended on the point that is on the circle in the remaining part of the circle. So the angle here we get y. This angle will be, sorry, the angle x will be twice of angle y. So angle y will be half of x. So you can write, you can say this as x and this will be 2x. The angle subtended by the arc at the center will be twice the angle subtended on the remaining part of the circle by the same arc. So this is theorem 1. Now, this is a chord and it separates the circle into two segments. We call this as minor segment and this as major segment. Here, you can make angles from this major part of inside the major part of the segment. You can make angles. In this theorem, the angles formed in the same segment are equal. So the angle here. So the angle ACB, the angle ACB will be equal to the angle ADB. So this is the theorem 2. The angles in the same segment are equal. Next, we have This is diameter. So we get two equal segments. So we call this as semicircle. When you make an angle inside a semicircle, this angle will be 90 degree. This angle will be a right angle. So the angle subtended in a semicircle will be right angle. Angle ABC will be 90 degree. This comes on only when AC, the line AC that passes through center O. So we have three theorems that comes under angles. First, you have the angle subtended on the center will be twice of the angle subtended on the remaining part of the circle. And the second, you had the angles that form in the same segment are equal. And the third theorem is the angle that is formed inside a semicircle gets the value 90 degree. So these are the theorems that comes under angles in a circle. Next, we have cyclic quadrilaterals. When you get a quadrilateral where its point, the vertices of the quadrilateral that lies inside a circle, it is called a cyclic quadrilateral. So the theorem one is you have the angles are A, B, C, and D. So the theorem one is the opposite angles. When you consider A and C are the opposite angles of a cyclic quadrilateral, and B and D are the opposite angles in a cyclic quadrilateral. So in a cyclic quadrilateral, the opposite angles are supplementary. So A plus C will be 180. Similarly, the angle B and D will be 180. So this is theorem 1. The theorem 2, we have A quadrilateral N in this quadrilateral ABCD, you have the side D that is produced. So the angle that has formed in the exterior angle that is formed when the side CD is produced. So this angle will be equal to the angle that is opposite. It has to be opposite interior angle. So the angle X will be, here will be X and this also gets the same. So the angle CAB will be equal to the angle BDE. What's the reason you get here? The exterior angle that is formed when the side CD is produced will be equal to the opposite interior angle. So you have two theorems in cyclic quadrilateral. One is opposite in a cyclic quadrilateral. The opposite angles will be supplementary and the angle that is formed exterior by producing the side CD is equal to the angle opposite and interior. Next, we have tangents. You have a circle with center O. Here, a straight line that touches a point on a circle. A straight line AB that touches point on a circle. This is called tangent. So, the theorem 1 is the straight line drawn through the point on a circle and that has to be perpendicular to the radius. The straight line that is drawn through a point on a circle and this straight line should be perpendicular to the radius that same circle. So to prove this as a tangent, you have two conditions. One should be, it should pass through a point on a circle and it should be perpendicular to the radius that same circle. Now you have a circle and you have an external point. So you are drawing a tangent starting from the external point. So you have drawn two tangents that starts from point B and one tangent that meets the circle at point A and another meets the circle at point C. Now the tangent, the length of A to B, the length of A to B and the length of B to C will be equal. So AB will be equal to CB. So remember, if two tangents that is formed from an external point, that is drawn from an external point, will be equal. Now you have an angle that is formed between the tangent AB and the tangent CB. You have an angle that is formed between two tangents. And the point in the in the center is O. If a line is drawn from center to the point B, here this angle will be bisected. So the angle here will be bisected and you get equal angles of these two, equal values for these two angles. The second theorem will be the angle that is formed between the two tangents will be bisected by the straight line that is drawn from center. And you have another theorem. The tangent AB is making an angle here. The tangent AB is subtend an angle here. As well, the CB, the tangent CB makes an angle here. So these two angles will be equal. So the third theorem is the angles subtend at the center by the tangents will be equal. And the last theorem you have is you have a circle and you have a tangent. Now you have a circle and the tangent meets the circle at point O. And it has a chord that is drawn, a chord AO. The angle that is formed between the tangent and the chord. This is the angle that formed between the tangent and the chord of a circle. It will be equal to the angle that is subtended by the same chord. So the angle that is formed between the tangent and the chord, this angle will be equal to the angle that is subtended by the same chord in the circle. So we call this part of the circle as alternate segment. So we say the angle that is formed between the tangent and the chord will be equal to the angle that is subtended in the alternate segment. So that's all for the uh, theorems that comes under circles. We have discussed the theorems that comes under circles as chords, angles, cyclic quadrilaterals, and tangents. Now we'll move to essay question. So we'll discuss the question 11 from 2024. In the given figure, AB is a diameter of a circle. So they have given AB is a diameter of a circle. Let's say the chord that passed through center is diameter. And CD is a chord which is bisected at X by AB. The chord CD. CD is a chord that is bisected at X. So here the chord CD is bisected by the diameter AB. So you get a 90-degree here. Moreover, CP is perpendicular to PAR. CP. They have drawn a point, drawn a straight line CP. So the straight line CP is perpendicular to the line, to the tangent PAR. So the straight line CP is perpendicular to the tangent PAR. Copy the given figure in your answer script and join OC. We have asked to join OC. So when you do these type of essay question, remember you have to copy the figure they have given and you have to mark all the points they have mentioned in the text. The first question, show that PAXC, PAXC, you have to show PAXC is a cyclic quadrilateral and that the chord AC, the chord AC, you have to show that the chord AC bisects PCO. This chord bisects the angle PCO. So in the first question, we have two parts. First thing, you have to show that PAXC is a cyclic quadrilateral. So we know the angle CPA. The angle CPA equals 90 degrees. The reason is the straight line CP bisects the tangent PAR. So you get 90 degrees here. Then we know the angle CXA. The angle CXA will be 90 degree because we have given the chord CD. The chord CD is bisected by the diameter AB. So CD bisected by AB. So we know in a cyclic, to prove PAXC as a cyclic quadrilateral, you can get the angles opposite in a cyclic quadrilateral are supplementary. So you know angle CPA and angle CXA equals 180. Here you get 90 and here you get 90, so you get 180. So PAXC, the quadrilateral PAFC will be is a cyclic quadrilateral. The reason is opposite angles are supplementary. So you have proved quadrilateral PAXC is a cyclic quadrilateral. Now we have the second part that you have to prove chord AC. The chord AC, that is a straight line that joins AC, is a chord that bisects the angle PCO. O is bisected by the chord CA. To prove this, you have to make sure this angle and this angle are equal. You have to prove these two angles are equal. You know the line OC, the line OC and OA. These two are equal because you know the line CO and OA are radius of this circle. So the lines CO and OA are equal. So you get the angle here. This angle and this angle will be equal. So you write angle OA OA, sorry, OAC will be equal to the angle OCA. The angle OAC will be equal to OCA. Reason CO and OA are radius. You can write CO equals to OA. You can write this as a reason. And then you know the line AB, the diameter AB and the line drawn TP are parallel because you have proved this as a cyclic quadrilateral and you know this angle and this angle is 90 degree. So opposite angles in a parallelogram is equal. So the here opposite angles are equal. So you can say this as a parallelogram. So the line AB is parallel to line CP. So from here you can get alternate angle. Angle OAC. The angle OAC will be equal to the angle ACP. You know, this is the alternate angle. So you have the angle OAC equal to the angle ACP. The reason alternate angle and AB is parallel to CP. Now you have proved this angle and this angle are equal. So you can say the angle OC, the angle OCA is equal to the angle ACP. Therefore, the chord CA bisects the angle PCO, the angle PCO. So it bisects the angle PCO. CA bisects the angle PCO. The next question they have asked, state with reasons two angles which are equal to BAR. You have BAR. So they are asking the angle BAR. when you see the theorem, the angle that is formed between the tangent and the chord, the exterior angle that is formed between the tangent and the chord will be equal to the angle that is formed by the same chord in the alternate segment. So DAR will be equal to the angle ACD. The angle formed between the tangent and the chord is equal to the angle that is formed by the same chord in the alternate segment. So you can write the reason angle in alternate segment. The next is you can take this angle. Here CD and PAR are parallel. So the angle formed this alternate angle. You get an alternate angle here. So DAR is equal to the angle CDA. You can write alternate angle and CD is parallel to ER. That's all for the question 11 in 2024. Do the question number 9 in 2023. So we have question number 9 in 2023. They have given C is the center and AB is the diameter of a circle in the given figure. So they have given C is the center and AB is the diameter. You know, a chord that is drawn through a center is the diameter. So AB is a diameter. The radius CD is perpendicular to AB. The radius CD is perpendicular to the diameter AB. And it intersects PB at R. We have the point P here. It joins a straight line, and the straight line joins the point P and point B. It intersects the radius CD here at R. The tangent to the circle at P. The tangent to the circle at P and CD. The line CD, they extend and meet at point Q. The other tangent to the circle drawn from Q, the other tangent that drawn from the point Q meets the circle at S. So first, you have to draw the figure and you have to mark all the data given. Next, they are asking to join PA. Show that PACR is a cyclic quadrilateral. PACR. Okay. So the quadrilateral PACR has a cyclic quadrilateral. They have given the line, the diameter AB here, it is bisected by the the radius CD. So you get a 90 degree at ACR. So the angle ACR is 90 degree. You can say CD bisects AB. Then you have an angle here. This is the semicircle and the angle subtended in the semicircle is 90 degree. So you get the angle APB. Sorry, the angle APR. The angle APR is also 90 degree. Reason, angle in semicircle. So you can say the opposite angles are equal, not, sorry, the opposite angles are supplementary. ACR plus APR gives 180. So the angles ACR and APR are supplementary. Therefore, you can say the quadrilateral PACR is a cyclic quadrilateral. Next, we have to prove QPR. The angle QPR is equal to the angle QRP. The angle QPR. This angle, the angle QPR and the angle QRP. We have to prove these two angles are equal. We can say the angle PA the angle PAC is equal to the angle PRQ. We know the angle that is produced by the side of a cyclic quadrilateral will be equal to the opposite interior angle. So you can write the angle PAC is equal to the angle QRP. The angle, exterior angle that is produced by the cyclic quadrilateral is equal to opposite interior angle. Then we can say the angle QPR, the angle QPR will be equal to the angle PAC. You know, the angle formed between the tangent and the chord. The angle formed between the tangent and the chord, it will be equal to the angle that is formed by the same chord in the alternate segment. So the angle QPR will be equal to the angle PAC. Therefore, you can say the angle QPR will be equal to the angle QRP. Now you have proved these two angles are equal. Next, they have asked, join RS and show that RQS is an isosceles triangle. You have to join RS and you have to prove the triangle QRS is a isosceles triangle. You have already proved this as these two angles are equal, therefore these two sides will be equal. The side PQ will be equal to the side QR because the angles, the sides opposite to equal angles are equal. Or else you can say PQR is a isosceles triangle. Therefore, the side PQ and QR are equal. Then you can say PQ and QS are equal. PQ and QS are equal because you know the two tangents that formed from an external point will be equal in length. So these are the tangents that form from exterior point. So tangents are equal in length. Now we can say QR, the side QR is equal to the side QS. The side QR is equal to the side QS. Now we have proved two sides of this triangle are equal. Therefore, you can say the triangle QRS is a isosceles triangle. The reason is opposite sides of a triangle are equal. So, we have discussed the theorems that comes under circle and we have discussed two essay questions. If you have any doubt, you can ask me and we can end the session today. If you have already done the past paper questions, you can say, so we can prepare the different type of questions other than the past papers and discuss with you. So we'll end the session today. Thank you.